Welcome, everyone. Thank you for coming this evening. This is the fourth of a five-part webinar series exploring aspects of the long-term planning and implementation of smart distribution grids. My name is Terry Jo Lovas, and I am the ISGAN Communications Working Group Manager. So here's the plan for today's webinar. I will be telling you a little bit about ISGAN and the Lighthouse Project, and then I will hand over to Kai and the rest of the panel to discuss this phase, which is implementing distribution planning. So what's ISGAN? ISGAN is the International Smart Grid Action Network. It is a joint initiative of the IEA and CEM, bringing together government representatives and technical experts to exchange knowledge, develop practical insights, and support evidence-based policymaking. We promote international collaboration to support the development of smarter, more resilient, and more flexible electricity systems to enable the energy transition. ISGAN is the only global government-to-government forum on smart grids. We are a group of national experts from 25 countries and the European Commission committed to supporting the global shift towards smarter and more reliable electricity distribution systems, which are key to meeting clean energy goals. There are 6 active working groups engaged in various aspects of smart grid development and deployment. These working groups have created an array of reports and tools, and I encourage you to visit our website to explore those. Our vision is to accelerate progress on key aspects of smart grid policy, technology, and investment. ISGAN emphasizes the importance of strong, reliable, resilient, flexible, and affordable power grids, supported by the digitalization of the electricity system for achievement of goals on the grid edge. The grid edge includes the integration of electric vehicles, renewable energy storage, and demand-side management. We implement this through the facilitation of dynamic knowledge sharing, technical assistance, peer review, and project coordination between contracting parties. Activities we leverage to achieve this include outputs such as policy briefs, technical and discussion papers, conference presentations, and webinars like this one. So as the members of ISGAN explored the planning and implementation of smart distribution grids, it became apparent that these processes include many external influencing forces and actors with diverse roles and goals. This often results in actors operating in silos and under conditions of uncertainty within governance frameworks that are slow to adapt. So in 2023, ISGAN developed the Lighthouse Project to facilitate collaboration between these actors and across countries and sectors, helping to overcome challenges like fragmented planning and slow policy changes. It was decided that the best initial focus area of the project should be long-term planning and implementation of smart distribution grids under uncertainty, with the vision of increasing ISGAN's impact, accelerating the energy transition by mobilizing actors in new ways around smart grid knowledge. Having the ISGAN community mobilized around this unified theme and employing a synergistic project structure enables us to connect different knowledge and perspectives, joining forces and exploring new ways of working. In doing this, we engage more effectively with our stakeholders, resulting in more impactful and cohesive external communication. It promotes practical solutions and long-term thinking. The initiative aims to strengthen global efforts to modernize energy systems through shared learning and innovation. To achieve this, we need a shift in mindset from the traditional reactive grid planning approaches that rely on rigid master plans and are static to a forward-looking, adaptive, and scenario-based planning approach that can effectively manage long-term uncertainties. This new approach envisages planning and decision-making that is dynamic, continuously evolving, and built on collaboration among key actors. It embraces complexity, incorporating scenario-based planning, risk assessments, and resilience measures to navigate an ever more unpredictable energy landscape. And it prioritizes its strategic intelligence solely on past data is no longer viable. Decision makers need advanced modeling, real-time data, and strategic foresight to stay ahead. Phase 1 of the Lighthouse Project resulted in a series of tangible outcomes, including a policy brief, a pilot of our knowledge hub, a global workshop series, new collaborations between our working groups 3 and 7, enhanced online communication, and a framework on long-term planning and implementation. That framework is what we are exploring during this workshop series. Phase 2 began into October 2024 and is even more ambitious with activities around knowledge sharing processes, a casebook showcasing pioneering global examples of innovation in the long-term planning and implementation of smart distribution grids, further development of the Knowledge Hub as a resource for people to learn more about the framework, workshops with key actor groups to explore challenges and opportunities in advanced grid planning processes, deep dive activities by ISGAN working groups on key technologies and aspects relevant to the Lighthouse project theme, collaboration with other international organizations and work streams, and the ongoing webinar series. These activities will combine to deliver a set of high-impact knowledge products to be launched in conjunction with the Clean Energy Ministerial later this year. So to tell you more about the Lighthouse Framework, the focus of today's webinar, and introduce you to our panelists, I will now hand over to Kai Heussen, a senior researcher at DTU Wind and Energy Systems, specializing in energy system flexibility, distribution networks, and distributed control. He currently leads the 3-phase InSight project on low voltage distribution grids and has co-led European research projects with a strong focus on test design and validation of complex energy systems. His academic record includes over 80 peer-reviewed publications, and he is actively engaged in international collaboration and standardization efforts, including leadership roles within IEA initiatives. Over to you, Kai.
So thank you, Deviko. It's really a pleasure to have the chance to present to you today. I've been involved with the phase 1 for a little bit as an expert coming from working group 5 on testing, but also contributing to the planning. So now it happens that we are looking into implementation, which we very much care about when we are looking at testing. But what does the framework do for us for the whole domain of distribution planning? It intends to provide a structured approach and helps navigate system complexity, and it fosters a shared understanding of collaboration in long-term planning. And together that creates a forward-looking mindset, which really differs from the reactive planning that we consider as a baseline. So rather stereotypically, we could formulate that the proactive and adaptive planning is considering flexibility and adaptability more directly. It's considering a focus on uncertainties by offering a scenario-based approach in decision-making processes to be actually collaborative and a lot more collaborative. That has been also very much the focus of the engagement process. Then the integration of stakeholders throughout the planning process, not only in the last hearing, the use of data, and we will learn a lot more about how that is useful in planning from the webinar today. Looking at timelines instead of a 10-year cycle that you start after 10 years again, to do it more iteratively. That is something implemented in some countries already, so it's a good practice. And the planning philosophy to look at this as an evolving process. So with this framework, we have had already a few webinars. So the previous webinars prepared today's webinar, in a sense, looking at foresight, at strategic decision-making, at long-term planning, and assessment and decision support. And today's webinar on implementation subsumes the previous aspects, because when you want to implement planning in distribution operators, you have to consider basically all of the above, but then also the tools and the actual actors that implement the distribution network planning and dispatch. So with this focus, we'll came with the title of Implementing Distribution Planning, Flexibility for the Energy Transition. So the keyword of flexibility is floating around a lot and is hovering over distribution networks, sometimes as an opportunity, but also sometimes as a threat, because if the flexibility is not for the distribution network, well, then it could harm the distribution network. So we really have to take care of it also in our planning process. You could say that implementation deals with detailed designs of solutions and deployment aspects. And in terms of issues, the actual solution, again, implementation. But really, all of the bullet points that are here do affect implementation. The contracts, the stakeholder engagement doesn't stop. And the economic risk management is also important when in the planning tools. So we'll hear from our experts soon about how this is integrated. And to this end, we have invited a number of really qualified experts. We have Tobias Svensson, who is a senior technical specialist in power engineering at E.ON Sweden, a distribution network operator. And then we have Emil Larsson. He's a Ph.D. and CTO of Utiligize, who's providing services and especially also planning services to distribution network operators. And Mark McGranigan, EPRI Fellow, coordinator at EPRI Europe, will teach us more about the state of the art and rollout of flexibility solutions. I myself was introduced. I'm a researcher at DTU and have also worked with flexibility in the past. Before we start with the presentations, and the first presentation will be Tobias, I'd like to just set the scene with this question. The question we'll be addressing is, how do we implement the planning of active distribution grids that enables flexibility, and by this to accelerate a timely, cost-effective and resilient energy transition? So the highlighting brings some keywords in, because we will hear Tobias about active distribution grids. Flexibility is enabled. And we will hear from Emil how the planning of grids, also accounting for flexibility, will help to accelerate, make better plans. And finally, we will hear in a bigger picture how this flexibility can enable resilient energy transition from Mark. So I look forward to your presentations. The next presentation will be Tobias. So Tobias, I'd like you to share your screen, and I will stop sharing here.
So, okay, thank you, Kai. And I just wait until the pictures are presented. And so now you should be able to see. So I would like to thank you for the opportunity to present what E.ON in Sweden are doing in the area to increase the grid utilization with new and smart technology. And I'm Tobias Svensson, and as Kai said, I hold a position as a senior specialist in power system engineering with focus on the controllability of our grids and also to remain the protection of the grid. And E.ON in Sweden, we owns and operates grids for voltage levels up to 130 kV. And we have a quite large geographical area in Sweden, from Malmö in south to Sollefteå in the north of Sweden. And for you who hasn't been in Sweden, you have to look up where these cities are located. So, and today we have roughly about 1 million customers connected on different voltage levels in our grid. So during this presentation, I will go through the system challenges and why do we think that we need to think different in the future than we have done in the past. We will look into if we always have limitations in capacity or if this differs during time. I would like to point out some kind of policy principles that forms the baseline of how we have worked with the area, and give a small example for the toolbox that we use in grid planning, and take one practical example as a final slide. So if we look at the system challenge and why do we think that we need to have controllable grids? Yes, we see that the electrification of the industry, together with many connection requests for energy storage facilities and renewable energy productions, will increase the energy demand in Sweden. At the moment, our customers want to build large solar facilities or PVs, but the energy source has been changing during the years due to political decisions and the energy price. But the problem is more or less the same. We have a lot of customers that want to connect to our grid. And if we look at the predicted scenario that the Swedish authority, Energimyndigheten, has presented, we can conclude that we will not be able to meet the increased demand only by building new overhead lines or substations. So we need to figure out what can we do instead and how can we meet our customers' expectations. And if we look at the root cause, we took a lot of effort to find out what are the industry looking at for obstacles to be able to do their energy transition. And the baseline was the lack of grid capacity. The next one is the power shortages. We need always to have the production and consumption to align and be able to meet this in our grid. We have the investments cost, and we have the technology innovation, which drives the demand for the industry. And as a DSO, we can address the grid capacity problem, which we can also see as the baseline in the limitation identified by the industry. So this fits us quite well. And that means that we can do this in different ways, but we always needs to look into the most cost-effective way to do the transition and changes. So if we look in the grid capacity problem, we can see that there is not always limitations. If we look at the duration curve, we can see that there are only a few hours of the year where we have actual limitations in the grid. But when we look to connect a new customer, we always need to look into the historical loading of the substation, and we need to consider the N-1 criteria. We should always be able to provide our customer with a grid connection. And this means that we, during a normal operation, always have a lot of capacity, both in the grid and substations that are not actively used, and we are trying to find a way to use this. And of course, we would like to have this as a low impact to our customers as possible. So our ambition that we have formed is to always offer a connection. And if needed, we should look into the contractual agreements to find a way to connect the customer. And we only want to build new assets when they are permanently needed. So we try to use our existing grid as much as possible. And by doing this, we need to standardize the controllability and to look that we have the same controllability of our grid and our customers' usage of the grid across the planning, the operation, and the customer processes. So, okay. How can we do this in a grid planning way? Well, to be able to move our position when evaluating a connection, we have formed a couple of principles, which security, that is the first priority that we have. But then we need to make the decisions risk-based, consistent, and transparent for our customers. So the controllable grid solution must also remain non-discriminatory. So we can't, or we shall treat all our customers in the same way. And by this, we can see that the flexibility markets, the conditional agreements, and other kinds of automation solutions are complementary tools that we can use. But at first, we need to look into how much capacity do we have. And by this, we try to create a system to be able to see how heavily our grid is loaded and describe this in operating states. So the transition between the system states when we go from a normal operation to an alert or emergency operation when we get a contingency and the N-1 criteria. So all of our assets has been prioritized and checked where we are in the actual operating state of the grid and what will happen when the customer connects. And that is the error here that we look into for each customers, what happens when we have no contingency, and if we get one, will we move between the system states? And if we move to an alert state, we probably will have to do some kind of arrangements to be able to connect the customer. And that gives us the toolbox. So if we look at how we can plan an action due to a customer connection, we always want to choose the right action that gives the least intrusive or intrusion to our customers' needs. So if we can handle a connection with a reconfiguration of our grid, that is always the easiest and preferred way. But we can see that if we have the opportunity to together with our customers, find ways to control or steer the customer's usage of the grid to time slots where there is less congestion, this gives us a lot of opportunities to connect more customers into the existing grid. And if we look at the market-based flexibility, that is also something that we have been looking into areas where we have a lot of customers want to connect. Then we have actually started a market-based solutions where the customers can sell or buy capacity in the grid. And if we look at the one practical example, we can see that we at the moment have tried to make a centralized system integrity protection schemes that we have implemented in our SCADA. And this gives us the possibility to connect customers with a condition that they take part of this protection scheme, which means that they will be able to control their power according to the utilization of the grid. And it enables us to govern and make alignment with the national requirements in how we as a DSO can connect the customer. So the architectural principles for this practical example is that we use the existing OT infrastructure, which we already have connected to all our substations. And this gives a very small cost for the customer that are connected during these circumstances. We have tried to make a modular architecture where we have separated the central logic, the local command execution, and the real-time monitoring. Even if it's in the same system, there are building stones that we can combine to be able to handle the grid as efficient as possible. And operational characteristics for this is that we get the real-time evaluation of load and system states. And by this, we take automatic activated decisions and actions that doesn't affect the operator that are operating the grid at the moment. And that was the practical example that I wanted to show you. And that was my last slide according to the presentation. So you have seen why we think that we need to think different. We have looked into how we manage the operating states to be able to give us more capacity in the existing grid. And I finished off with a practical example that we are building at the moment. So that was the last one, and I guess I hand over to Emil directly.
So my name's Emil. I'm CTO of Utiligize. Utiligize is used by 15 DSOs to estimate available capacity in the grid, process connection requests, and make investment plans. Basically, it's a digital twin that we provide with a lot of different investment algorithms. And we can see today there's a grid with a little bit of spare capacity, but already in 2030, 40% of assets will be overloaded or have a voltage issue. So it's a very severe situation that we are observing and forecasting for our customers. To give an idea of some of the things we do in Norway, we provide automated connection processing, so new customers can be approved in 3 days instead of 4 weeks. And we can prioritize the queue by technology type. That is something new that seems to be coming into many different countries. In Norway, we're processing 12,000 low voltage connections automatically per year, and it's around 90% that get approved automatically, and under 10% that get flagged for manual inspection and reinforcement. So not only does this speed up new connections to the grid, it also has significant savings compared with doing all of this manually. So I thought I'd use my presentation today just to show some data and some results from the grid that we think are often hidden or not available. And I'll start with electric vehicles because today it seems to be electric vehicles that are really shifting load, and also especially the low voltage grid, and it's electric vehicles that are the number one for needing solutions. We can see in the low voltage grid that they now account for around 17% of peak load. So this is a really significant result. This is across 95,000 substations and cables. They only drive around 8% of the peak load in the medium voltage grid and around 4% in the high voltage grid. And then when we go to the transmission grid, it's actually less than 2% today. And these are results from all the DSO customers we have in Denmark aggregated together. So that is, it's a bit of a shock to see that EVs can have such a large impact at the low voltage and insignificant impact today at transmission. Maybe shouldn't be a shock. We can see for some primary substations, so this is, in this case, 60-10 kV substations, EVs already account for up to 50% of the peak load. And the first graph on this, I apologize that some of it's in Danish. The first top graph shows the total loading in megawatt from 2021 to today. So on this substation, it's up to around 2.5 megawatts. The second plot shows the number of electric vehicles that have charged, the green line showing in the last week. So we're up to, and then the blue area is the last 6 months. So we're up to over 1,000 electric vehicles charging under this primary substation. And the last one is the coincidence factor. So you take the top number divided by the middle number, and then you get the coincidence factor. You would expect the coincidence factor to fall as the population gets larger. The coincidence factor reflects how much we charge at the same time for the same technology. And in fact, it's not falling, it seems to be increasing. And it is the response to spot prices and using apps like the Monta app to schedule your charging when the price is lowest or when the CO2 mix and the energy production. These are really driving up coincidence factors. You wouldn't expect that. So what tools do we have today to mitigate this increased loading from electric vehicles? Well, if we look at Europe's largest flexibility market, and that is UK power networks, which is part of the market in Great Britain, behind closed doors, they will admit that this market is a failure. Just 15% of tendered zones result in a successful clearing and activation. The market in Great Britain is 450 times larger than the second biggest flexibility market in Europe, which is in the Netherlands. And our hypothesis could be that using direct control, which is a flexibility market, to counter congestion caused by indirect control, which is wholesale prices like spot prices, is a fundamental mismatch and a mistake. If you look at each of the tendering rounds in UK PN, and one of the fantastic things with the Great British market is that all of these results are publicly available through their open data platforms. Then you see that up to 20%, 22% of each round is tendered. Then only a very small proportion of them are actually activated over the lifetime of the round, which the contracts can last up to 2.5 years. So activating flexibility at around up to 15%, but often slightly under 10%, is not. Of course, you could say the value it's creating is much larger than such a low percentage suggests, but it has been seen as a disappointment, and these are shockingly low activation numbers. If we look at the experience from Denmark, most countries, of course, haven't really rolled out a full flexibility market yet. Time of use tariffs in Denmark have moved the peak consumption to a significant amount for a significant number of assets to the middle of the night, and the price is low. So this is how EV owners are rational. Send them a price and they will respond. They will combine their tariff with the spot price, look at the overall price, and get a response. This heat map shows how likely you are to have congestion within a certain hour. And we see now in December and November at 2 to 3 a.m. some serious congestion due to these time of use tariffs. So they've moved the problem hours to some new hours. The tool that we have in most jurisdictions that is useful for trying to make the best out of the capacity situation that we have today is the non-firm connection. And then you can jump the queue. When we look at the numbers we have in Denmark today at the primary substation level, typically you can get 3.5 megawatts. That's the median spare capacity after N-1 conditions at 10 kV. But if you want double that, you should expect 50% to be non-firm. So 50% of that can be curtailed at any time. And this is the kind of numbers that would be useful for industry coming online to understand what is the risk. And if 50% of your connection is non-firm, you should expect around 600 hours curtailment per year on average. So this is what I love about this number is no matter what the mechanism is for activating flexibility, it begins to give an idea of the consequences and the scale of flexibility. How many hours per year is it that it's relevant? And that's, of course, assuming that it's only new loads, new industry that is flexible, and we're not activating flexibility from existing customers. And that's quite a big assumption. Because, of course, it's, of course, from new customers who, when they're getting connected to the grid, they have the right technology to do that. When the grid can't keep up, then we can see batteries can deliver. If you're going to be curtailed 600 hours per year, a 4-hour battery is enough to ride through 95% of these curtailment events. So it's, again, that's something that new industry, new industrial connections can factor into their plans when deciding if they're going to go for a non-firm connection. Just to conclude, our recommendations, what we've seen is that better capacity maps, short-term forecasts, and dynamic tariffs almost seem inevitable. DSOs could publish duration curves potential connection points, so customers can quickly and easily decide if they can live with the curtailments that will be expected at that point. 7-day forecast, short-term forecasts, is something that utilities are now doing for loading, voltage, and also the temperature of all assets. That means that when you are on an interruptible connection agreement, you can minimize the risk of being there and not bid incorrectly into day-ahead markets. There are also lots of interesting lessons from the Netherlands and Finland. Finland, where Fingrid has, and also the Netherlands have semi-public queues for all new connections, so there's some transparency about where you are. And high-resolution capacity maps that could be updated weekly. The grid is shifting so quickly that the ones that we've seen so far that are quarterly aren't very usable. They're outdated as soon as they're published often. In Great Britain, DSOs have been hampered by not having meter data. And if you look at the tender results, there's a lot of failures at the low voltage. Another reason for the failure is the wholesale market arbitrage is far more attractive. Commercially, you want to be trading on the spot price, and you don't want to be limited by distribution congestion. And yeah, finally, dynamic tariffs, they seem almost inevitable, but we should be focusing on how they can be made fair and how they can work with the other tools in the toolbox. Thank you.
All right, how's
Yes,
that?
it seems to work.
Okay, great.
Go ahead, Mark.
I'll go through these pretty quickly. This is going to be very consistent with the presentations that we've had on E.ON activities and utilize capabilities, and emphasizing the need to include flexibility, probabilistic approaches, and many new capabilities in our distribution planning activities. This is just a brain dump list of some of the things that we really need to be incorporating. Many of them are coming in tools like Utilize and others that are out there. And I'll go through a few of these just to illustrate some of the priorities that we have on the R&D space to help utilities around the world implement new distribution planning capabilities in order to take advantage of flexibility characteristics. And as we heard from the E.ON Sweden example, don't invest in the grid unless we really need to for long-term low growth needs, and take advantage of the capabilities of technologies, customers, flexible contracts, and everything else. But in order to do that, we need to represent these things in our distribution planning tools. We need to understand what the potential characteristics are of customer flexibility, dynamic ratings, other non-wires alternatives, what assets can handle, and so on. So let's just take a look at a few of those things. One thing for sure, we do have to invest in the grid. The Euroelectric Grid for Speed report was a good one a couple of years ago, still very valid, showing that we basically need to do something around doubling our investment in the grid in order to deal with growth due to electrification. This is before we even began to understand the impact of data centers in the equation. Electrification of heat and transport itself is creates a huge need to invest in the grid, not to mention resiliency needs as we look at climate change impacts. So lots of factors driving investment needs, and we need to make these investments as efficiently as possible. That's the point. We heard about hosting capacity. Hosting capacity is a capability that needs to be in our planning tools, obviously, for identifying locations on the grid where we can process connection requests faster and connect people up to inform the public of where there is opportunities. And this applies whether we're talking about generation like PV, or we're talking about new loads like big EV charging stations. The hosting capacity concept is the same, and our tools need to be able to deal with that. So one of the things that we work on closely. We need to move from basically accommodating distributed resources, where distributed resources are participating in wholesale markets and coordinating with the TSO, and we're just dealing with it on the distribution side, to, as in the US where we have FERC 2222, we're at least be able to continuously assess the potential impacts of those distributed resources on a distribution system in coordination with how they're participating in broader markets, into the future where we're really integrating those resources, making them part of the way we operate the distribution system, maybe using the smart inverters and grid forming inverters for voltage control, using flexible contracts and so on. So that's a path that we need to take, both in terms of the way we operate the grid as well as in our planning tools. Customer, absolutely key. And this goes right to our planning tools. How are we going to represent customers with their own individual controls? We talk about dynamic tariffs. That's great. How do we address that in our planning tools? What's going to be the impact of dynamic tariffs at the individual feeder level? You know, as we plan investments in the distribution grid, how much can we count on customers to participate as a function of maybe what the rewards are for that, what the dynamic tariffs are, or if we have other market structures to reward customers for participating, how are they going to participate? So the complicated nature of the customer model in our planning tools is one that definitely is still a very strong research topic, a lot more work to be done there. And it's made even more complicated by GPR requirements so that we can't really include a digital twin for every customer in our planning tools, because we're not supposed to know that the exact behavior of every single customer. So even though that would be ideal, you know, have a nice digital twin for every customer, then as we aggregate them, we'd really result in accurate models. We have to be careful in how we do that. Microgrids is another topic for planning tools that is worth talking about as we invest in resilience. Can we invest in local resilience solutions? We're seeing a lot of this in California, where customers with battery storage or other resources at their own level have the capability to ride through interruptions when they're being shut off for safety purposes, when there's potential for wildfires and things like that. So can we plan this? Can we plan distributed resilience capabilities as part of the way we operate things? Personally, I think vehicle to grid technology makes this even more attractive, where we have big batteries in our driveway. Taking advantage of those, both for flexibility and resilience, allows us to kind of stack the value streams for those resources, but we need to make that part of our planning model. And as we do all of this, we need to really understand that our planning tools have to model the way we operate. So all of these technologies have control characteristics associated with them, whether they're energy storage devices or controlled electric vehicle charging or just customer behavior. That's going to roll into the way we operate the grid, and we manage the DER out there and take advantage of the flexibility of customers. And we need to actually model those control characteristics in our planning tools as well, so we can simulate how that's going to work from a planning perspective. So we use the term operational planning to deal with that. And to make all this work, we need to just keep in mind that it's not going to be broadly deployed and implemented unless we deal with the interoperability issues. So this is an area where we have a lot of research activities and a lot of activities like the Mercury Consortium that's working on interoperability at the device level. We have a project called Flexit that's working on kind of the platform level interoperability and where OpenADR 3.0 fits in, along with the individual device standards like the Open Charge Point Protocol and things like that. So interoperability is key. It influences how the assumptions in terms of how these resources are going to be taken advantage of as we look at them in our planning tools as well. So as we do all this, we have to it's a planning process. We need to balance these conflicting objectives around affordability at the customer level, reliability and resilience, and then allowing the customer to be part of the equation and really trying to get to this upper right-hand quadrant where we have an affordable system, but we also have a reliability and resilience system, even as we allow more and more connections so customers can participate. So that's where we want to go. We've worked with a number of customers on what we call grid modernization roadmaps, and one of the things that we go through there is look at the maturity of the different tools and systems that they have, planning being one of those, and kind of go through the capability that's needed in the grid modernization challenges and the energy transition, and allow individual utilities to kind of self-assess where they are with respect to the long-term needs of some of these things that we've been talking about. So really understanding where you are in terms of maturity in this space and help prioritize investments and implementation processes as we're talking about today. And one of the things that I think can help with this is work going on in open source community, open source software. It doesn't mean you need to use open source software as your primary tool for doing these studies. Typically in planning studies, you're using commercial tools, Power Factory, Synergy, SIME, and many others. But as we develop new tools and models and capabilities, having an open source platforms for all the research community to work together on, and then making it open source so that all of these new companies like Utiligize can take advantage of these developments and go ahead and incorporate them, so that we end up seeing these capabilities in all the tools that are out there. And so we have OpenDSS that's been incorporated in many people's planning tools that they're using. There's an LF Energy project called the Power Grid Model that will probably integrate OpenDSS with. And so these are some things to keep an eye on as you look at what new capabilities are being implemented. And probably the biggest one is taking advantage of AI and automating this process and linking in LLMs to manage the interface with the operator and take advantage of analyzing the results of each case, actually running the cases with the tools that are out there, and then analyzing results, producing the reports. Really, things like this can really reduce the connection process queues, as we heard from Utiligize. So those are some of the things that are priorities at the R&D level, and we're seeing as the examples that we heard from the last two presentations are good examples, is very consistent with these needs. So thanks a lot for the opportunity to join the call. It's been great.
Yeah, thank you, Tobias, Emil, and Mark. This was a lot of nuggets to pick up on here. So we reserved some time for a discussion, and well, I'm glad we talked before what could be some questions, but I would like to, from a perspective of DSO decision-making in practice, how are DSOs currently making real-world network planning decisions for new capacity? And that was highlighted. It was electric vehicles and renewables are sort of the primary hosting capacity, but we shouldn't forget that industry and electrification happens also at other big loads, like data centers are discussed a lot. Other industry, electric heating is a big topic in Denmark as well. So are those discussions happening in coordination with stakeholders, and how are basically decisions for going for additional capacity traded off with non-wire alternatives? Is this through discussion with the stakeholders? Is it a planning decision that the DSOs make individually? What is your experience? And I'll just start with Tobias.
Yep.
As the DSO.
Yeah, thank you. And my expertise is in the 130 kV grid, and I will answer the question accordingly to this. So when evaluating a connection request, we look at the grid capacity with reference to the customer's expected power profile, the available power forecasts, the planned projects in the grid, and several different cases from different power flows due to weather market conditions. We evaluate about 15 to 30 cases, each one for 11 years forecasts when we make our decision. So that was the baseline. And for each of the cases, we need to look into the contingency analysis according to the N-1 criteria. So, and if we find a congestion or a limitation in our grid due to this, we use the toolbox which I presented earlier, which gives us a efficient way to connect the customer. And as I said, we always want to make the customer connection opportunity. And in some cases that needs that we make this together with the customer and say that in certain circumstances you need to be able to control the power outage for your industry, and this is actually quite popular if we can say that you are allowed to connect now without any grid reinforcement, and you have to be able to control your power for about 10 to 100 hours a year. That was, I think it was Emil that showed these kind of numbers as well. And a lot of customers say that, okay, but when we will get the limitation, the energy prices are high, that will be no problem for us. So I say that we make this in collaboration with our customers to find the best solution in the place that the customer wants to connect.
Right. Thanks, Tobias. I'm just going to highlight that. So this is for large industry customers that connect to this one, and they are able to get into the dialogue with you. It makes sense. It's not hundreds or thousands of requests. And then you are able to actually provide them a specific curtailment suggestion. So that's where the dialogue really starts. You do the computations, you predict the congestion, and you actually share that information with your customers.
Yes.
So they can make an informed decisions. Maybe we'll just move this over to Emil. Do you know if there are, where does that dialogue break off? If you go lower in size or competences, is it possible for all DSOs to make that kind of full process? And I'm aware, like under 30 kV, that sounds like high voltage for Denmark. So if we go down in voltage level, how does the dialogue continue?
So in Denmark for the last 2 months, all big connections above 3 megawatts have basically been stopped by the Danish DSO, citing a lack of capacity. And we were awaiting a new government here to make progress on new rules where you can discriminate between technology types, basically putting data centers to the back of the queue. And the argument is, if you have to choose between a hospital or an industry providing several new jobs or a data center, the local community will always put the data center last. So we're actually still awaiting that you can connect anything above 3 megawatts at all right now. And at the smaller scale, DSOs will have a dialogue with the customers, but What they won't do is they'll say what the alternatives are. So today you have to request for a specific point of common coupling, you know, a specific bus, a node in the topology. And if there's not capacity there, you aren't given, typically, most won't give you alternatives. So that is clearly quite frustrating for those trying to get onto the grid. There is, what we can say is positive right now is the Danish TSO has just given all DSOs a deadline of August 15th to submit their capacity needs and their expected growth in the distribution system that they operate. And this is going to be a regular process starting every quarter. So what has historically in Denmark been a very bad cooperation between the TSO and DSO is changing now, it's about time. And so hopefully that we will have more consistent rules and more consistent information on, for example, how many hours you can expect to be curtailed, because that's not something that DSOs in Denmark tell new customers who are coming in on a non-firm connection. The risk is entirely unknown. So hopefully the having this national dialogue means that we have more consistency there and a better process for and understanding the expectations that come with non-firm connections.
Thanks. Mark, if you want to pitch in on this question, you're welcome to.
Yeah, I might just throw out, from examples in the US where maybe the requirements to implement everything through a market are not quite the same. You see some good approaches like Green Mountain Power having a program to implement customer storage on the customer side of the meter as a program where they control the storage and can take advantage of that to participate in the New England market, but also to manage constraints on the distribution grid and all DER in general being directly controlled by the utility to curtail or manage constraints with the agreement of the customer, maybe associated with a payment. Commonwealth Edison in Chicago has a program for any PV systems or distributed generation systems over 100 kilowatts, where they pay the customer to allow them to have control of that resource and manage it in combination with constraints on the distribution system. So there's a few examples out there where, taking advantage of flexibility and being able to implement it as part of distribution operations are being successful as non-wires alternatives when the number of hours per year that you need to take advantage of that is not going to destroy the economics of the resources in general.
Thanks. A quick note, we have discussed that we could extend a little bit the discussion time. So if you still have questions online, participants, please do write them up now. But we have a very interesting discussion going on, and I'll just continue. I'm going to do the big shift now, going from the implementation right now, the capacity needs, to directly toward the forward-looking aspect, because that's designing the contrast between the pressure that the grid operators are facing right now and what the regulators can do. I mean, we heard now the case from Denmark that the regulators is specifically asked to make a priority queue. But looking ahead, sort of, what other regulatory and market changes do you see critical to enable DSOs to fully embed flexibility into their planning investment, but also be able to provide the capacity that's required to enable the energy transition? And now that is sub-bullet to that one, because we've seen in Emil's slides the emphasis on the pressure on the low voltage grids and the lack of data in most places still on how low voltage grids are congested. So can the regulators on a regional, national, maybe on a transnational level do something to help grid operators, distribution distribution network operators to relieve the pressure. The priority queue was an example that was mentioned. Are there other regulatory needs that that you see needed? And maybe we'll start in a return path. Maybe Mark, you have a first response here. So from a global perspective, and then zoom into Sweden and Denmark afterwards.
I'll just say that I think the ability for the DSO to take advantage of energy storage and electric vehicle charging in a more direct way through programs with customers would be extremely valuable. It's really complicated to only be able to take advantage of those resources through third parties and aggregators, especially as we're considering using them for resilience as well as flexibility. So, you know, how we use energy storage and invest in energy storage. Electric vehicles are going to be an energy storage resource. They already are in the Netherlands. Coming up with regulatory approaches so the DSO can really use those resources with confidence and put them into their planning tools and take advantage of it requires changes. It doesn't work the way it is right now.
Very true. Tobias, what's your direction?
Yeah, I can second Mark on this. We need to have reliable and resources to be able to use when needed in the congestions in our grid, and this is something that I think that we need to work together with the authorities and the regulatory to be able to find the best solution both for us and for the customer, to be able to give a connection and manage the resources the best way in the complete system. And I think that this is quite similar in both Sweden and Denmark. Actually, do you have any other opinion, Emil?
No, I actually had two other points. Well, kind of related. The first, Catapult UK, a UK consultancy, they published a result saying that 80% of the value of flexibility is not in deferring investments, but it's all sorts of other things like facilitating cold start after a blackout, or being able to reduce costs during scheduled maintenance. So from a regulatory standpoint, framing making flexibility available for other things rather than just being hung up on investment deferral would probably be productive. And then just another point, 2026 was the year where our customers all became cash flow negative. So this is the first time where they have to go out, certainly our customers have to go out and borrow money to make the investments needed. And it can still be a profitable business because the WACC, I'm not quite sure what the English term for it is, but the interest you can get through your revenue cap is still greater than the interest you have to pay the bank. But it is still a stumbling block. It is a problem. It slows down the process, and it's something we should look at. When DSOs, if they weren't able to borrow, they would actually be losing money right now because the investment burden is so high. That's something that every regulator is going to have to look at right now because it's a new world for the DSOs. They're not used to it. It's a risk for them, and it complicates matters.
Thanks. In the interest of time, I'm just going to keep with one last question to round off. So we've discussed the near term, the planning decisions that are here and now. We've discussed what the regulatory needs sort of in the planning flow. We've heard something about investments and the value flexibility, what needs to be done. But there's also a difference among the DSOs. Some DSOs are sort of 1 million or more customers and basically in-house can build a big competence. And I think E.ON is a big concern. And Utilize talked with smaller and larger DSOs. Mark, you've talked with many. What are the concerns regarding these other regulatory impositions? We have more planning needs. We have to consider security and transparency. Isn't there a need of some sort to look at interoperability, not just from a standards point of view, but to see if the industry as a whole and the service providers for that industry, and that's not just Utilize, there are many small IT companies and medium-sized faculties that have to work with supporting the transparency, especially also of the low voltage grid. Does the industry need more guidance on security and transparency so that information shared between stakeholders, both on the end user side, but also on the service provider side, becomes more fluent? So can we say anything in that direction? What are initiatives that you have already seen in your countries that increase the transparency, that help to guide security, and that means cybersecurity and transparency, and trades them off? So this is a complex area, but I'd like you to pick something just for reference where I see it is tying in. Mark, you mentioned the hosting capacity map, and you give detailed grid information. We've seen an outage in Berlin where that detailed grid of information leads attackers to target those load attacks. So where do we need the regulator to make it possible for DSOs to make the right trade-offs? And how can we capacitate them to address also these institutional issues that are not flexibility markets, that are not the economic framework, but...
You want to start?
Yeah, I think you can do a start and give the others
obviously,
time to reflect.
Security and transparency are both critical issues. Sometimes they're actually conflicting objectives to some extent. But I will say that I think the UK example of the Open Networks Initiative and the Open Data Initiatives and the transparency that they've created, mentioned it. It's actually a great thing driving innovation, having as much data open as possible, and the risks that it increases cybersecurity concerns or something like that, I think are overwhelmed by the potential advantages in terms of driving innovation and creating technological advance and new solutions. So I think it's an example of a win-win there. In the U.S., we're in the opposite situation. Nothing is shared, and it's every utility has to do their own thing. No one can kind of combine data to come up with new solutions and new understandings that will drive the industry forward. So I think the transparency and openness is. I'm a big fan of it, as you could tell from the open source comments. That anyway, I think openness and sharing really drives innovation, and I hope we can move in that direction and still deal with the concerns associated with privacy of data for individual customers, and by anonymizing information and dealing with cybersecurity concerns. I don't think those are that have to be that much of a conflicting objectives.
I completely agree. For your first point, security by obscurity is not security at all. So anyone saying that transparency increases the risks, well, it can do, but any security expert will tell you that you're just papering over the real issue. So transparency breeds innovation. It allows new solutions to come online. We need a lot of new solutions over the next 10 years, over the next 5 years. And what the UK has done has been in many ways unique, making so much of it transparent. I hope other countries follow their lead. The biggest hack of the power system that I'm aware of was, of course, in Poland in December, where 500 megawatts of generation was taken over by Russian hackers. That was an exploit. The official report said it was an exploit through their VPN that was protecting SCADA and other assets. There was nothing about transparency that caused that. And what's more is what's interesting actually is our customers don't actually really believe the official report. They went out and installed sabotage monitors and substations across Denmark. So it's the security threats are it's the same old security threats. It's making sure that there isn't physical access, and when there is a single point failure like a VPN, because DSOs and TSOs haven't implemented zero trust networks, just making sure it's up to date and making sure it's monitored. I think it's important that we push back on that narrative, that and because I keep on hearing it, I hear it from people inside the power system industry claiming that transparency, hosting capacity maps are a security threat, and I think it's bullshit. I think it's done to just to delay progress, and unfortunately, it is a conservative industry, and there are those that have the interest of delaying progress because it can be a threat to an existing business model.
Okay, I think that in Sweden we actually have a regulation that says that we, as a DSO, needs to make our grid development plan public. So you can find it on our website, and of course we need to look into what kind of information that we put in the public information, but you should be able to find a geographical area where you have less congestions by just looking at the development road that we see as a DSO in our grid. And from a transparent point of view, that gives all the customers the same opportunity to see where are we able, or where do we have the greatest chance to be able to connect as quickly as possible. And from the TSO point of view, I can see that they have published more or less the same kind of grid map where there are capacity at the moment. So I think that we are doing something in that area to try to be transparent. And of course, there is always the we want to get the customers to connect to our grid. That's the point from our point of view, and we would like to be as attractive as possible by giving a lot of opportunities to be flexible in the power consumption and be able to make a connection due to that possibilities, actually.
Right.
Well done.
Yeah, thank you so much for your answers. This was very enlightening. I really enjoyed the discussion. I'd have a lot of follow-up questions, but we can't take them now. So thank you very much also in the audience who managed to hang in there. The recording and the slides will be shared with the registered participants. And well, I look forward to meeting you again. And thank you again for joining us today.